All right, guys, so we're gonna go through some word problem stuff. I'm gonna post another video that's gonna be attached to this in a second. We're gonna talk about how we solve word problems. Biggest thing when we're going through word problems is we identify what's a total, what everything equals, what is the coefficient that goes with the variable, and very typically what you'll see is in a word problem, whenever something says each or is asking for that missing thing, that's where the variable is going to go. Okay, so the first problem that we talk about, there's buses, there's kids, there's a total, there's a car, and so it asks for how we find out how many kids were on each bus. Well, it talks about there being 6 buses, there were an additional 7 kids in each car, and there was a total of 331 kids. Well, it's really important in this problem that when we identify what needs to go where, 331 is our total, so that's going to be equals 331. Write down numbers as you see them because that might help you as well. We have 6 buses. We don't know how many kids were on each bus. Whatever we don't know and we see the word each, that's going to be our x or whatever variable that we want to use. So we're going to have 6x plus 7 equals 331. And I'm going to run through that in the video right after this. Really important when we're going through problems, guys, we really take a look at our total, our each, that missing thing. Typically, when something's missing, that's going to be the variable. And then understanding either is something being added in or is something being taken out for the second part of your 2-step equation when it comes to word problems. I hope the next video helps. We're going to run through the exact problem that I just talked about, and then you're going to go and tackle those problems after on Google Classrooms. It's going to be posted. Stay tuned. If you have questions on word problems, make sure you ask me in the meetups that we have afterwards. All right, guys, in this video, we're gonna run through some of the word problems that I'm gonna post. I'm gonna do a few examples with you and just go through how we would solve them, how we would put them together, and we'll just work our way through this. So we're gonna be looking at 2-step equations. So that means that's already telling you you need to come up with something that will have 2 steps. Now that might seem really simple, but it's really, really good to understand that. So when we're reading this problem, it's important to really read through and highlight what is going to be put where within our problem. So 331 students went on a field trip, 6 buses. I'm gonna just highlight some important stuff. 6 buses were filled to capacity and 7 students traveled in cars. Now, the question's really important for this too. How many students were in each bus? Now, when you're reading a word problem, whatever the clue, like in this case, the bus, that's telling us what we're looking for. And what we're looking for is going to be our x. Now, how many buses were there? There were 6. So right off the bat, I know that we had 6 buses. We don't know how many were on each bus. That means that's going to be our variable. Plus 7 kids in cars for a total of 331 in all. It's really important to understand what's going to be your total in these questions, okay? That really helps because that's going to be what everything equals. So I'm going to just move this up. Now we have an actual equation. We just run through it. Well, how do we get rid of that 7? We've got to subtract from both sides. So now we have 6x equals 324. Okay, I'm going to move this over into the next question so I have some more space. So what do I have to do? I've got to have 6 equals 324. Well, now how do I get rid of that 6 so that I can get x all alone? We divide by both sides. I now have x alone, and 324 divided by 6 is 54. So we go back, how many kids were, or how many students were on each bus? Well, 54, and we can test that. We can test that by then going 6 times 54 plus 7 will equal 331. And when we punch that into a calculator, 6 times 54 equals 324 plus 7 equals 331, 331 on both sides. So when we punch in the variable back into the equation, it's correct. We know we're looking good. It's really important when we are working on problems like this that we understand there's our total. We had 6 buses. We had 7 students plus, and remember, and means we're adding in, and how many on each bus. Whenever we say each, that usually means that's our variable. Okay? Next, question number 2. We're gonna do this one together as well, okay? So Aaliyah had $24. Boom, there's your total right off the bat, okay? To spend on 7 pencils. After buying them, she had $10, okay? How much were each pencil? Well, how much each pencil, the 7 pencils each, so we know it's gonna be 7x, 10, and 24. Now you might be asking yourself, well, is it gonna be positive, or are we gonna put subtracting, or are we gonna put addition there? Well, after buying them, she still had $10. Well, that means she's got $10 left to spend. So that means she has it. That means it's like in your bank account, in her wallet, she has it. So we're gonna say add 10 or positive 10, okay? Then again, now we have our 2-step equation, and we run through okay, so what we do to one side, we do to the other. I'm just gonna write over the next question. I hope that's all right. So x equals 2. And we can always check that by then going back to our original equation and seeing if, when we punch in 2, do we get 24? Well, 7 times 2 is 14, plus 10 equals 24. So both sides equal 24. And that's how we know we've done something correct, because if both sides of the equation are the same, we are looking good. All right, in this problem, we're gonna look at how we find the sum of 3 consecutive numbers. It equals 72. What is the smallest of the 3 numbers? Now, we don't know what the numbers are. So all the numbers are gonna be x. And we need to get to 72. Well, the first x is just gonna be x plus x again, but we're gonna add one more because it's the next number. For instance, let's just guess. If this was 16, if they're consecutive, the next number is going to be 16 plus 1, which is 17. But I can't just put that. I have to put x. The x has to stay the same, but we're going to add the 1. So the next number, the third consecutive number, is x again. It's 16 plus the 2. But it's not 16. I'm just giving you an example, okay? Because what we need to do is we need 3 numbers that are consecutive that add up to 72. So whatever this number is what we base everything else off of, okay? So again, x is going to be repeated, and that's going to help us actually with the next step. So we know that we're dealing with 3 consecutive numbers. So what we need to do is actually combine some like terms. Well, how many x's do we have? Well, we have 3. How many constants do we have? We have 1 plus 2 equals 3. Now it's going to add up to 72. Well, now we actually have our two-step equation that we were looking for. So we're going to subtract 3, subtract 3. I'm going to move this over just so I have some space over here. So we're going to have 3x equals 69. Now we're going to divide by 3. That cancels. I've got x all alone, and I have 23. So my smallest number is 23 because I need consecutive numbers. Now remember, to start off, we had x plus 1 because it's 23 plus x plus 2. Well, if I punch that all in now, well, 23 plus 1 is 24, plus 23 plus 2 is 25. So there are my 3 consecutive numbers that when I add them up, I get 72. And remember, that was a really critical part of this question was the sum, add it all up, of 3 numbers equals 72. What are the smallest of these numbers? Well, it's actually our first number that we started out with, that x. It's 23. So what's the smallest number? 23. 23 plus 24 plus 25 equals our total of 72, and it's our sum of these 3 numbers. So I hope that helps. Tackle the next couple problems. Number 4 will be an interesting one. Use the same idea here. All right, in this question, we're going to look at number 11, okay? Jill sold half her comic books. Well, do we know how many comic books? No. So guess what our variable is? It's going to be our comic books is X. Well, she sold half of them. Even though we don't know how many she sold, she's going to be halving, so she's dividing by 2. Then she bought 16 more. Well, when we say bought 16 more, she's adding to her collection. And she now has 36, which is our total. So that's going to equal 36. Now, with how many did she begin? Well, we don't know how many she began with. Her comic books are the variable. She halved them. Then she bought 16 more. Now she has 36. Well, now we're just going to work through this problem. So we're going to get rid of that constant. Okay. And we're going to have, on this side, we're going to have 20. And now we've got x divided by 2 equals 20. Well, how do we get rid of this 2? We're going to divide by 2 or multiply by 2 because we're dividing. And now on this, I'm just going to move this over. X is isolated because that cancels out. And we've got 40. So again, really just taking your time going through these, just take your time going through these 1 and 2 step problems. And remember, take your time really understanding what needs to be what. She now has 36. Well, if she has them, that means that's her total, okay? Jill sold, that means she got rid of half. Again, we don't know how many she had. She bought 16 more. Well, where's our variable need to go? It needs to be that numerator. So take your time really identifying what needs to go where. It even helps, guys, even if you don't know what sign to put, you do know that the number 16 has to go in there somewhere. You do know that 36 has to go in there. Typically when there's a total, it's going to be the equal sign. If she's adding more, she bought more, that means she's adding to her collection. She's going to add 16. She halved whatever she had. We don't know what her total was. This is what she had at the end.